Okay, so we're going to start to process these Muse files, and I've organized here some of my files, which I recorded in one folder. So here you see I have recorded some data, eyes closed, I call them eyes closed, and some eyes open. And I have 4 files for each condition. And for the first day, so these were recorded on separate days. And for the first day, for instance, I recorded eyes closed before eyes open. For the second day, I recorded eyes closed after eyes open. Third day, eyes closed before eyes open, etc. So it is a randomized setting. And now we want to process that data in EEGLAB. So how do we do it? I also have a folder process data, and that's where we're going to put the data that's been processed. So first I start MATLAB, so I click on MATLAB. And then I start EEGLAB, so you have to go to the folder that contains EEGLAB here, and then you type EEGLAB. And then we're going to import one data file. So from last time, the last exercise, one of the last exercises, you should have this menu, import from Muse monitor application. If you don't have it, go back to the previous tutorial so you can install the extension to import these files. So I select this menu and then go to tutorial Muse, my raw data, and I'm just going to select the first file. So it's importing the data files, it's asking for name, so I'm going to say eyes closed 1, pressing OK. As you remember, if we just go and plotting the data, nothing shows up. That's because the data is offset. So as I mentioned in the previous video, you can either remove the DC offset and then you'll see them, or we can filter it. So we're going to filter the data. First step, filter the data. Before we filter, it's always good to remove, just if there's a global offset, just remove it, because then the filter works better. So remove mean of each channel. Okay, so again, to get there, I press Tools, remove baseline, and then I press OK. So that's done. And then I go filter the data, and you select the first option, basic fear filter. You might not have the additional ones here because they're extensions. So if you have not installed the extension, you don't have these filters. But this one you should have. And then I'm going to put, as in the previous video, I'm going to put 1 hertz as the lower edge of the frequency band. So it means everything below 1 hertz is removed. We don't have to plot the frequency response, so just press OK. Okay, now it's filtered. It's asking me what you want to do with the new data set. We're just going to overwrite the previous one. So press OK. So again, I went to filter the data, this filter, and selected 1 hertz and press OK. Now if we scroll the data, you see we don't have to we don't have to use that menu. So that's the data that's been recorded. And the next thing you want to do before you do group analysis is remove all the artifacts. So I'm going to make this a little bigger. And now I'm going to show 30 seconds of data. So again, to do that, go settings, time range to display. You click, and then you would select here 30 seconds. So this is going to show me 30 seconds of data. And here it's hard to see anything, so in the scale, that's the scale right here, I'm going to put 200. Now I can see what's in the data. This channel is bad, it's a bad channel. Here you can see these are probably blinks, so I don't want to process that. Also, for some of you, you have more data. It's like you recorded, for instance, a big portion of time in which the data wasn't being collected, so you'll have to remove that. So for instance, if you know that the first 20 seconds of your data is you were doing something else, you were actually not doing the task you're supposed to do, like meditating, for instance, you would just go here, select, and that would select these portions for rejection. So we just say we're going to reject that data. If you selected, so then you can scroll back and forth. If you want to merge with this region, you go here. So for instance here, nothing was happening before 1 minute. I was just setting up. So I would just select this region. Then I have to select the bad portion of data. Bad portion of data is basically anytime something large like this happens, the data is bad. So that includes all of this time here. And that's why it's good to record a lot of data, because then you can reject it. You can reject large portion of data. So this region, this one, that doesn't look too good. Here we have 4 seconds of good data. This is not good. I would reject that portion of data. This is not good. Here again the blank. Here this is good data. Here that's W's, this L peak. Remove this. Remove this. Remove this. Remove this. Remove that portion as well. So in this case, there are blanks. So these are blanks. If you have a task like meditation that's eyes closed, then you might not have so many artifacts. This one's probably an artifact as well, so I should remove it. There we go. This I don't know. Any doubts? Remove it. This, remove this. This little thing here as well. And then you go back and forth. No, this doesn't look that good. It's good to do 2 passes in your data as well. So here I had 5 minutes of data, and you see you lose a lot of data. So I'm mostly looking at the first 2 channels because the other 2 seem very noisy. Again, this looks like blank. And that's the end of the data right here. So I've selected all these portions of data, and now I'm going to press the reject button. It's telling me it's marking the events. I'm again pressing override it in memory. And then it's always good to do a second pass. So here I'm going to again change the length of visible. It's like 30 seconds. And again change the scale. I'm going to put this time 100 so I can see more details instead of 200. So we got some data here, that's pretty good. At the beginning, this seems to be more of this here, so I'm just going to remove that portion. And this also looks pretty noisy. I'm going to remove that portion as well. So we'll be left with this. So it's better to have, and this I'm going to remove as well. It's better to have fewer data, but very good data, rather than more data and bad data. In this case, that's pretty extreme, and in general, I would remove about 20% of the data. Here, the data is relatively bad, so that's why I have to remove much more of it. Plus, I know that if I'm left with a segment that's about 1 minute, which is the case here, you have 160 seconds, 284, That's 20 seconds, plus another 30 seconds here. So we have about a minute, 2 minutes of data, and that's enough. We don't need more data than this. Okay. So now it's done, and now I'm going to save this dataset. So save dataset as, and then I'm going to go to my process data, and see, I already have it here. So ISO01 isClose.set. And I've saved other data files. I've also saved the number 2, number 3, number 4, etc. So then you press save. I'm just going to press cancel here. It's already saved it, so I already processed it. So I don't want to process it again. And then basically you do that for every single file. This was some testing I had to do, so I'm just going to remove these files. So after you process every single file, this is how it's going to look. You're going to have, for instance, 4 files here for eyes closed and 4 files for eyes open. This was the raw data, so they were .csv extension, and this is .set, so this is EEGLAB datasets. So now we have 8 files, and we've cleaned them all. They're all filtered, they're all really clean. We know there is no strong eye movements, whether even if the people have eyes closed, sometimes you have eye movements even with the eyes closed. So we know there's no strong deviation, no movement, and we can really look at the actual brainwave underlying this data. So what I'm going to do, I'm going to go here and hit clear data. So it's just going to clear everything in EEGLAB memory. Actually, it's clear study, clear all. File, clear study, clear all. And then I'm going to load these 8 datasets. So process data, and I select these 8 datasets. You can all select them at once. So again, so I go to, I don't select the raw data, I select the process data. Okay, so it's loaded the 8 datasets. Oops, the tag is wrong here. This is because I named them wrong, but these are the right datasets. They should be the name of the dataset should be renamed. But let's just continue. So then we're going to create study using all loaded datasets. So this is very similar to the other presentation, except now we're dealing with the Muse data. So using all loaded dataset, and then you can set the memory option here. That's the warning. So actually, I'm gonna ignore it this time. Then you go here, and now we have to define. So here we can see the file name. See, eyes closed 2, eyes closed 3, eyes closed 4, and here eyes open 2, 3, 4. And for the subject, we're going. So first the condition. So we're going to eyes open, eyes closed. Eyes closed. Eyes closed. Eyes closed. Eyes open. Eyes open. Eyes open. Eyes open. For the subject, now I'm going to enter. I only have one subject, but actually, if I want to do group analysis, and I have to pretend like I'm having, I need to do as if I have several subjects. When you want to analyze multiple sessions in EEGLAB, you have to pretend like you're doing several subjects. This has changed in the new version, but that's the way it is right now. So for instance, here I'm going to put the day instead of subject. So day 1, day 2, day 3, day 4, And this was recorded on day 1 as well, day 2, day 3, day 4. So if I had multiple subjects and just one recording per subject, I would just enter here subject 1, subject 2, subject 3, subject 4. Here, subject 1, subject 2, subject 3 for subject 4, and I have 2 files per subjects. Given here, I only have one subject recorded on different days. This is the way it needs to be coded. So that's the way you will need to code it as well. In the new EEGLAB version, you can define this more accurately. But that's the way it is in this one. So here so update asset info. That's not really important. You can check or uncheck this. It just means that the files which are saved on disk, you can update the information in these files or not. So we don't need to. If you leave it checked, it doesn't matter that much. So we press OK. Now it's creating the study. So it says that's 4 subjects. There's 2 conditions. 4 subjects, so it's really 4 days in our case. There's 2 conditions per days and 4 channels, etc. We're going to save the study. I'm going to call it Muse. Oops. Muse. Okay, it is saved. Now we go to the study design. And everything is already selected the way we want it to be selected. So this is our design 1. We can rename it eyes open versus eyes closed. And then we want to compare, so the first independent variable, we want to compare eyes closed and eyes open. And here we want to select all the days. So again, this is subjects, but if you want to process multiple sessions of a given subject, you would enter here. We don't have a second independent variable. Pair statistics means that here these were recorded on the same day, so we really want to compare eyes open, eyes closed on the pairs of days. So we would resave the study. All the rest we don't have to change. We press OK. Then we go to the third menu, recompute channel measures, and we have to select this because for this, if we just press OK, it's going to tell us we can't do interpolation, so we can't not interpolate missing channels, meaning finding the activity of some channels which we would have removed because we don't have the position of the channel, so this requires the position of the channels. Also, we haven't removed any channel. We've left all the channels, so we really don't need to use that. In general, you would want to use this one. And then we want to compute the power spectrum. We can just leave everything here as default. We press test, so that's the way it looks. I'm going to comment on the power spectrum in the next few minutes, but it just shows you, that's shows you the type of graphical output you would get, so you know what you're going to get. And then once you're done, you press OK. So it's going to pre-compute all the spectrum, so it's done. And then we can look at the data. So we would plot channel measures. We have our 4 channels here, and 4 channels recorded with the Muse. And as mentioned in the other lecture, this column is for plotting the grand average over the 4 days, and this column is for plotting individual days. So for instance, we would plot the spectrum here for AF8, and this would be for eyes closed, so the grand average spectrum, and this would be for eyes open. We can change the parameters, so we can overlay them on top of each other. So here I check parameters, plot variables on the same, plot first variable on the same panel. And now they're on top of each other. What we can also do is plot the individual days. So you see this is pretty clustered. you know, it's pretty consistent. Like when they have eyes closed on the 4 days, it's about this area, and this is the individual spectrum for the individual days. If you want to know which day, you can click on the little trace. It's going to just tell you, oops, you click on the, it's going to tell you exactly which trace it is. So for instance, if I click here, it's going to tell me trace 3, so that would be day 3. If you click on the figure, it's going to pop a new one, trace 4. You can get the individual days. And this is for eyes open, so you can see that's very different. And next week we're going to deal with statistics, but no statistics yet, but you can see that the two are very different. These recordings were very noisy. If they were right, we would see a nice difference at 10 hertz, because this is what we observe here. We observe mostly high frequency activity, which is probably reflecting muscle noise. So it's not that important. We're just looking at the spectrum at this point. And I think that's it for this. So import your Muse file, clean them up. Whatever looks like activity that you can see goes higher than, you know, deviation in multiple channels or a single channel, you remove, because the brain activity is much smaller than that. So whatever you can see, for instance, when my scale was 200 microvolts, it just wasn't brain activity, so I knew I had to remove it. Better to remove more than not enough. You do that for all your data files, and then you can create your study and change your study design and plot, pre-compute the spectrum and plot it. And that's it.